Alright, so this is for Wednesday's lecture. So using the conversion factor. So this is for dimensional analysis. So dimensional analysis is helpful for converting units, doing conversions and such. A unit conversion factor is a fraction whose numerator and denominator are equivalent measurements. Such common unit conversion factors are given below. You can also use the reciprocal of these. Reciprocal is swapping or switching around the numerator and denominator. So here are some common conversion factors. 1 foot is in 12 inches. You can also do 12 inches in a foot and so on. So you can flip them around and flip the numerator and denominators around. When you choose so you need to choose a unit factor that introduces the unit you want in the answer and cancels out the original unit so that the one you want is all that's left. So, for example, if you have inches per feet, feet per miles, whenever they multiply together, the feet will cancel each other out, giving inches per miles. If you multiply seconds per minute by hours per second, the seconds are going to cancel each other out, giving hours per minute. So choosing the appropriate conversion factor. If you want to do inches to feet, you're going to want to put inches on bottom. So 1 foot divided by 12 inches will cancel out the inches. So it would be that one. So if you're going from minutes to hours, you'll start with minutes. And you'll choose the one that has minutes in the denominator. So you would use the conversion factor 1 hour to 60 minutes. If you're going meters to centimeters, you want to cancel out meters, so you use meters that are on the bottom. So 100 centimeters to 1 meter. Note that this PowerPoint puts an imaginary 1 under your thing. I usually leave that one blank. You'll see a difference in notation. I'll go over it here in a second. So the first step in converting 8 yards to feet is what conversion factor do you want? So we know that there are 3 feet in a yard, or 1 yard is equal to 3 feet. You want to cancel out yards to get feet. So you use the one that will cancel out the units you want to change. So set up the problem and multiply the measurement by the conversion factor. You want yards on bottom, so it'd be 8 yards times 3 feet per 1 yard. And then you perform the multiplication. So you'll see they like doing this notation, so where they put imaginary 1 under your 8 yards. I don't like doing that, and I also like using the grid instead of doing multiplication like this, but whatever makes more sense to you. So we can see that the yards cancel out, and we're just left with feet. So for example, what they had was 8 yards times the conversion factor of 3 feet to 1 yard. And what they do is they put parentheses and we have 8 yards to 1, and they do 3 feet per 1 yard. The yards are going to cancel each other out, and you're left with just feet. And so we're left with 24 feet per 1, and you can get rid of the 1 by doing 24 feet. What I prefer doing is using a grid. So you start making a grid, and your conversion factor, 3 feet to 1 yard. And now we can see this is cancels out, and we can just make this equal to 24 feet, and you can multiply the top, and then it'd be divided by 1, which is just 24 feet. So a bucket holds 16 quarts. How many gallons of water will fill the bucket? If you use a unit conversion factor to convert the units, you start with 16 quarts. What are the two conversion factors comparing quarts to gallon? So we have 4 quarts to a gallon, or 1 gallon is 4 quarts. So we want the one that will cancel out, so we want quarts in the denominator. Multiplying those together, quarts will disappear and we only got gallons. So 16 times 1 gallon is 16 gallons, and then we have, because the quarts cancel out, you have a 4 in the denominator and 4 gallons on top. One bag of apple weighs 64 ounces. How many pounds does it weigh? 6 ounces. So we would use the conversion factor of 1 pound to 16 ounces. The ounces cancel each other out, so we would end up with 64 times 1 pound divided by 16, and all we're left with is pounds, and that's equal to 4 pounds. Again, I would prefer you if you used a grid. Darren drank 2 liters of water. How many milliliters of water did he drink? So there are 1,000 milliliters of 1 liter. So we put liters on the bottom and then work it out. So doing rate conversions, use a unit conversion to convert the units, which will cancel each other out. So if you want to convert 80 miles per hour to feet per hour, we would do 80 miles per 1 hour. This is what 80 miles per hour means, 80 miles per every 1 hour. And we know that 1 mile is equal to 5,280 feet. So we'd put miles on bottom, so it'd be 5,280 feet divided by 1 mile. The miles cancel out, and we're left with only feet and hours. So it's equal to 422,400 feet per hour. If you wanted to convert feet into feet per hour to miles per hour, begin. So we know that 1 mile is equal to 5,280 feet. So we put feet on bottom this time to cancel out the feet. Working it out, we get 12 miles an hour. So to convert 32 feet per second to inches per second, again, we'll use the conversion factor. We'll cancel out feet and give us inches. So we know that there are 12 inches in a foot, and we put foot on bottom, inches on top. The feet will cancel out, giving us 384 feet per second. A craft store charges $1.75 per foot for lace. How much per yard? So we know there are 3 feet in a yard. We put feet on top this time to cancel out the feet on bottom. So work that out. So using the grid, we're given $1.75 per 1 foot. Using the grid, we want it per yard. So to cancel out this foot, because it's in the denominator, we would use 3 feet on top to 1 yard, so that the feet cancel each other out. A foot divided by a foot is just 1, and 1 times what's left is what's left. So this would be equal to 175 times 3 divided by 1 yard, which would be equal to $5.25 per yard. So the average American eats 23 pounds of pizza per year. Find the number of ounces the average American eats per year. So again, we'd set it up 23 pounds per 1 year. We know that there are, for 1 pound, there's 16 ounces, and we want to cancel out pounds. So we put it 16 ounces to 1 pound on bottom, 1 pound on bottom to cancel out the pounds on the 23. So the average American eats 368 ounces of pizza per year. So a car travels 60 miles on a road in 2 hours. How many feet per second was the car traveling? So here it suggests that we set up the words first. We know it's in miles an hour, and we want to put it in feet per second. So we're going to need to cancel out the miles and get feet. So we're going to multiply it by some ratio of feet per miles. And we need to convert the hours into seconds. So we're going to put hours per second. So 60 miles to 2 hours times 5,280 feet per mile. You can also use conversion factors to convert hours into seconds. So there are 3,600 seconds in an hour, or you can just plug it in. And we get 44 feet per second. Again, using the grid notation I use, what I would do, and I still suggest doing what they did in writing down. So we're given miles per hour. We need to convert miles into feet. So I'm going to have some miles on the bottom and some feet on top. And I need to convert hours into seconds. So I'm going to first convert it into minutes. So you can put hours on top, minutes on bottom. And I need to convert minutes into seconds. So I put minutes on top, seconds on bottom. Now you can plug numbers in. It told you it's 60 miles for 2 hours. There are 5,280 feet in 1 mile. There is 1 hour for 60 minutes. And there is 1 minute for 60 seconds. Double check that everything canceled out. So miles and miles will cancel out. Feet stays. Hours and hours cancel out. Minutes and minutes cancel out. So my last units are feet and seconds. So this would be 60 times 5,280. You can ignore ones, divided by 2 times 60 times 60. And that gives you 44 feet for a second. You don't have to do the grid, but trust me, the grid actually helps. You could write it out like this, but the grid, I believe, works better. It's how I personally do it. Whenever I'm doing these conversion factors, I actually use the grid every single time. I hope that helped y'all with the homework. By the way, code word is Charlie. So the code word of the day is Charlie. I will release on Google Classroom asking for the code word. Make sure you put it in so you can be counted as present for tomorrow.